Today, we're going to dive deep, and I mean literally deep, to explore some of our planet's most incredible, most massive landscapes. The thing is, they're almost completely invisible. Yeah, forget what you see on land. The real drama is happening thousands of feet beneath the waves. So you have to wonder, right? How is it possible that there are canyons out there that can rival anything we have on land, but they're completely hidden from us? This isn't just some geological fun fact. It's one of the planet's great puzzles. Let's start by trying to wrap our heads around the incredible scale we're talking about. So, to really get what we're talking about, let me just ask you this. Picture the most epic, jaw-dropping canyon you can imagine. Now, what if I told you there are countless others that absolutely dwarf it, hidden away under the sea? Okay, let's put this into perspective. We all know the Grand Canyon, right? It's immense, world famous. But now look at the Zemshur Canyon, hiding out in the Bering Sea. It's almost a full kilometer deeper and more than twice as long. It's an absolute monster, and yet most of us have never even heard its name. You know, this one comparison really shows you just how massive and how mysterious our own ocean floor still is. So, the big question is, how does the Earth carve something so enormous in total darkness, miles underwater? Well, the answer isn't a gentle, flowing river. It's something way more violent, way more powerful. The best way to describe it is a massive underwater avalanche. The main force at play here is something called a turbidity current. And really, the best way to picture it is as this colossal underwater avalanche. But instead of snow, it's a super dense, churning mix of mud, sand, and water that can hit some pretty incredible speeds. And this whole process happens in 4 basic steps. First, you get accumulation. All this sediment from rivers just piles up and up on the edge of the continental shelf. Then you need a trigger. This could be an earthquake, a big storm, or sometimes just the sheer weight of the sediment itself. Boom, that unleashes the flow, this powerful current that just barrels down the slope, scouring the seabed. And the final step is erosion. You just repeat that process over and over for millions of years, and you end up carving a canyon. And here's the key to their incredible power. On land, rivers are just carving through air. But underwater, these flows are supercharged by the full weight and density of the ocean itself. And that gives them an erosive force that's it's almost unimaginable. But here's the thing. Turbidity currents, as powerful as they are, don't work alone. They're actually part of a whole team of geological forces all working together. So let's meet the other members of this sculpting crew. First up, you've got the most fundamental force of all, good old gravity. It's that constant, relentless downward pull on all that unstable sediment piling up. You can really think of gravity as the force that loads the trigger, just setting the stage for every single one of those underwater landslides. Then you have the master architect of the whole operation, plate tectonics. The slow, grinding movement of the Earth's crust is what builds those steep slopes in the first place. It creates weak spots along fault lines, providing the perfect terrain for these canyons to form, especially in places called subduction zones, where one plate slides under another. And finally, you have the persistent work of ocean currents. So if turbidity currents are the violent, heavy-duty carvers, you can think of deep currents and tides as the finishers. They work slowly, over thousands of years, helping to sculpt the canyon edges and, really importantly, flushing out debris to keep the canyons clear and deep. Now, what's really fascinating is that a lot of these canyons actually got a head start. Think back to the ice ages. Sea levels were way lower, so rivers flowed right across the exposed continental shelves, carving out valleys. Then, when the ice melted and the seas rose, those valleys were flooded. This basically created the perfect pre-made channels, an ancient blueprint, if you will, for today's turbidity currents to follow and carve even deeper. Okay, so we know how they're made, but why should we care about these giant trenches hidden in the dark? Well, it turns out they're far from just empty voids. They are absolutely vital for the entire planet. For starters, these canyons are major biological hotspots. They act like giant funnels, channeling nutrients and organic matter from the shallows all the way down into the deep sea, basically feeding entire ecosystems that would otherwise starve. Their steep, rocky walls create all kinds of complex habitats for deep-sea corals and fish. And get this, they can even act as highways for migrating whales. And from a geological point of view, their job is just as important. Think of them as the main arteries carrying sediment from the continents out into the deep ocean. This process literally builds the vast flat plains of the deep sea floor. And in that sediment is a buried geological record of Earth's history, holding clues about everything from past climates to ancient volcanic eruptions. To really truly appreciate these incredible features, you have to think on a completely different timescale. And you also have to recognize the amazing technology it takes for us to just get a glimpse of them.
You see, a single turbidity current might only last a few hours, but the canyons themselves, they're the product of deep time. We're talking over 100 million years. That number, it represents the immense patience of nature. Just countless earthquakes, landslides, and climate shifts over eons, all slowly, relentlessly sculpting these masterpieces in the dark.
And it's only right now, with incredible tools like high-resolution sonar and deep-diving robotic vehicles, that we're finally pulling back the curtain. I mean, for the first time in human history, we are actually mapping and exploring these hidden worlds in breathtaking detail. And that kind of brings us to our final thought. We've explored more of the surface of Mars than we have of our own ocean floor. So if something as monumental as a super canyon can lie hidden just off our coasts, it really makes you wonder, doesn't it? What other secrets are still down there in the deep, just waiting to be discovered?